All right, so we meet again today, and we will be going further. And the further thing is that we will look at the principles involved in the manufacture of the textured yarns. So, we understood there is a broad classification, and so we will go further. So, what have we learned till now is the terms and the definition related to texturing, right. So, what is called texturing, texturization, those are the issues we think, and the definition as to what kind of a process is a texturing process and what kind of a yarn could be texturing. And we also understood that it is not that the texturing process got generated, developed only after the advent of synthetic fibers. Actually, the work had started before, and people must have also found that a bulky material is a better from comfort point of view, and therefore, you can get different kind of structures which could be stretchable and which can retract and give you comfort. Also, we learnt about the advantages and possible applications of those kind of textured yarns, and we had done a broad classification. Okay, we done a broad classification of the textured yarns. So, let me just go back a bit, and we remember that the broad classification said that there is stretch yarn and a modified stretch yarn and a bulk yarn. So, you remember what kind of a material will be called a stretch yarn? What type of material will be called a stretch yarn? The one which can stretch up to 300 to 400%, and the one which are modified stretch yarns would be doing the same thing, but at a lesser stretch ratio. And we did say that if it is a stretch yarn, the stress strain curve of a stretch yarn would be something like this, and the modified stretch yarn would be something like that, and the bulk yarns probably may work like this, that they do not stretch, and therefore, the stress that gets developed in the yarn is immediately as you strain them, and this could be one of the ways in which you can find out whether it is a stretch yarn or it is not a stretch yarn. Today, as I said, within these classifications, we will try to see what type of a principle are used to generate a stretch yarn or a modified stretch yarn. Then if time permits, we will go to the bulk yarn, otherwise we will stop and do it next time. So, the stretch yarns. Okay. So, one of the process that has been used to produce stretch yarn is called a Helenca multi-step process. It is called multi-step because there are many steps involved, like there is a process which is to be done called twisting. So, it is a multi-step process. So, you have to twist. So, that is one. You remember which other process was also using twist? Last time we were talking about the historical perspective. You remember any name? Well, the one which was false twist, of course, we talked about, but in an earlier time we had a process which was used for texturing of multifilament viscose yarn, and therefore, twisting was used. Okay. That was called the Heberlein process, if you remember that Heberlein process. So, that also used twist, and this Helenca finally also uses twist. This was commercially successful process. So, there was a process in which you had multifilament yarn, you would twist them starting from some package, and after twisting you go through a next process called setting. That is, you must set the the twist. Now, how do you set would depend on what type of material it is. If it is a thermoplastic material, it is a non-thermoplastic material or whatever. Let us say it is a thermoplastic material. If it is a thermoplastic material, then maybe you will do the heat setting. And this heat setting, obviously from one package you have come to another package which is also twisted and has been subjected to some treatment like this. And after that the same package is taken to another machine for detwisting, and then after detwisting what you get is a textured yarn. So, you have a package, then you go somewhere and do the twisting, and then go somewhere maybe in autoclave, because you have to keep them for setting, and then go to another machine for detwisting, and therefore, it becomes a batch process. So, you will do many batches in one way, maybe there are many spinning heads, spindles where you are twisting, that you take the packages, put them in somewhere for setting, then take them out, cool them, detwist, and then get another package where you will have textured yarn. So, this is a multi-step process which is a batch process. So, significance of these steps, the significance obviously is unless you twist, you can't go to the next step. So, what will the twist give? If you look at anything called twisted material, so when you twist, possibly in this condition the filament, if it is a filament yarn, the filaments will be taking some type of a helical path in the yarn, and if they take a helical path, and then you do something which is called setting. So, after untwisting, theoretically and practically also, each filament probably may have taken some path like this, based on whether you are giving a S twist or a Z twist. This could be this or that. But interesting is the setting. If you do not do any setting, then yes, this will be twisted. You do untwisting, you will get untwisted. So, you will get the same material with which you had started. We therefore have significance of all the three steps, which we said twisting, setting and detwisting. And if this is what we do, we will get a textured yarn. So, principally you are twisting. Sometimes this type of method is also called twist texturing, that you are using twist as a medium of deformation. So, you are deforming the parallel bundle and then retaining that shape by some method and that setting. This is a line diagram of another method which is called false twist. So, the yarn comes from this side, maybe from a package, feed roller, you take the yarn, then there is something called a heater. So, the yarn passes over the surface of the heater and guided to another thing which is the take up roll, and between these two rolls you have, this is what we call as a primary heater. So, there is a heater if we are again looking at a thermoplastic yarn. If there is no thermoplastic yarn, then heater is not going to be the one which is the functional part, we will have to do something else. But let us say we have a thermoplastic multifilament yarn, then in that case we have a feed roller and a take up roller, and in between you have a heater. The heater basically is convex, so that when your yarn passes through this, it is generally in contact with the surface. So, if this is true, then we expect that the yarn get heated, but is the process different than the previous one? What was the previous process principle? Twist, set and detwist. The change that we are saying is false twist. It does not mean that we are not going to be twisting, it does not mean that we are not going to be setting, and it also does not mean that we are not going to be detwisting. So, all the three steps will be done, but in a manner where twisting, untwisting is happening in a manner which we now call as a false twist. Let us say you have a parallel bundle of filaments and they are nipped, for example, one at its point and the other at this point, they are nipped. If they are nipped properly and it is stationary, okay, it is not moving. If this is not moving and you twist from the middle, what do we expect? We expect that on one side the twist will be, let us say, in one direction, on the other side the twist could be in the, let us say, first was S, the other will become Z, all right, S and Z. So, if do the sum total of this, if it is in the absolutely middle, the number of twists above the twisting point and the number of twists below the twisting point are going to be same, one in plus direction, other in minus direction, and therefore, there is no twist or a false twist. Does it help in any manner in our texturing process? Unless and until we smartly do it, it does not matter, does not help. So, what do we get? We must do setting, but we must do twisting followed by setting followed by detwisting. So, what do we do? If suppose we have the same situation, like we have a take up roll and feed roll, and let us say, as we may say, this is moving upwards. Now, it is not stationary, actually it is moving. If it is moving and there is nipped here, this is a parallel bundle of filaments being fed up to the nip, and you are trying to do some twisting. So, this portion from here to this point will get twisted. The other portion must get equal and opposite twist, like the case which was here, all right. But what happens here is, because this portion which has just been twisted is moving up, so it gets the reverse twist exactly equal and opposite. So, the resultant is that this becomes untwisted. So, in the same movement, if we keep doing it, you start with an untwisted yarn, twist in between and go up, which you have again an untwisted yarn. So, you start with an untwisted yarn, and finish with an untwisted yarn. This is the principle of the false twist machine. So, one thing, the motivation is you did not, you wanted a continuous process. Continuous process, because we know that the profit, the speed, the production in a continuous process is likely to be higher. The batch to batch variation which you can see in a situation which is one batch to the other batch, the temperature, if at all, is may be changed, the levels may be changed. In this case, if it is a continuous process, then productions could be high, space requirements could be different, and quality variations may be less. So, how do we use this principle in the texturing machine or a false twisting machine? Is that there is a twister here, this is a twister, this is the feed roll, all right, this is the take up roll, in between we are twisting. So, what do you expect? If this is twisting here, the material above this would be untwisted, the material below this would twisted. So, the twist is actually flowing from this up to the nip of the feed roll. In between, what we have done also is there is a primary heater also has been put. The word primary here comes because in a next machine we can see there can be a secondary heater also. So, what have you got? You have twist and detwist taking place because of false twisting, and when the material is in the twisted condition, you are putting a heater there. And so, not just the heater, but you also have what I call as a cooling zone. So, setting in a thermoplastic yarn, there is a heating process and there is a stabilization process which we call as probably can come through cooling. If suppose you did not give this cooling length or did not give the cooling time, then false twist will do its job, twist and untwist, but the hot yarn which is pliable to change again will be untwisted while it is still hot. So, you will see whatever setting you want to do can be redone also. It is not only going to be untwisted, but it will also go to the new position which will be flat filament yarn. So, all these things that are written here called the primary heater is important, cooling zone is important, twister is going to do the twisting which means the false twist, that means deformation. After the twisting, it is a multi-filament yarn which is a parallel bundle, and then you can wind it up, and that is a textured yarn. Continuous process. Is that right? So, the principle of false twist is clear, and the general scheme of things are also clear, the sequence also in which it should happen. You can't have any other sequence, can't do setting before the twisting and can't do setting without cooling in case of thermoplastic yarns. If there are other yarns, then we will learn about it, how they can be set as well. So, what will be the structure of this false twist yarn? If you look at the structure, what will be the structure? You have to speak little louder, so that helical. So, the structure of this yarn also will be helical. One can design to make it Z or S up to us. So, if you have large long machine, so you will have different spindles, some of them may be running at S, some of them may be running at Z. You say, oh, what does matter, everything can run at S, yes, sure, you can run whichever direction you want to run. But when you make a final product, people may like to have one S twisted yarn, the next one as a Z twisted yarn, and S and Z and S and N combination. So, that whatever little biases can come, because a yarn has a tendency to get into a helical shape. So, if one of the yarn wants to turn this direction, the neighboring yarn if turns in the other direction, then you get a balance. A fabric, knitted or otherwise, would look balanced. So, in a machine you may have both running simultaneously or alternatively, so that the final product which you make is more balanced. So, structure of the yarn of false twist also is helical. So, another process which is used to produce stretch yarns. Remember, we are still talking about stretch yarns. Is called edge crimping. And what is edge crimping? You take a yarn over a sharp edge, under tension. If you take a yarn over a sharp edge under tension, and if you want to design something, you can let us say it is also easy to understand to begin with. Is also thermoplastic yarn. So, you can put a, let us say, heating device as moving. Alternately, you can heat the edge also, but maybe it is easier to put a heating device. So, you have a yarn which has been heated to a certain degree, which is sufficient for it to respond, goes over the edge and comes out. And you say, here we are starting with a yarn which is untextured, and here we are coming out with a yarn which is called textured. Not only textured, but I say it is a stretch yarn. You think it looks like a good idea or it is a bad idea? Good idea. The good idea part is that appears to be a very simple process. You are just moving over an edge. So, simple process is always good idea. What kind of structure that we likely to get here?
One-sided crimping, one-sided texture.
One-sided texture. Anyone else would like to respond as to what kind of a structure we are likely to get when you pass a filament yarn over an edge under tension which may be heated? What kind of a structure do we expect? Let us say, I say it also will be helical. You think it is a good statement or a bad statement? Or it would be like this? What will be? Second one. So, you are expecting that when you pass over an edge, you are likely to get this type of a structure, right? Convinced? But it is wrong. So, what you get actually is a helical structure. You gone to the florist shop to buy flower bouquets. That smart guy picks up a ribbon and then moves it over a just edge. What kind of structure do you see? Oh God, that is it. That means just by passing over an edge you can get a helical structure. And helical structure if you get, that means you can take this yarn or a filament, you can stretch it, it will recover, it will go maybe a large amount of extension or stretch, it will show. If it is nicely done, it will come back. It is quite possible that you take that ribbon of that florist and again stretch like this, it may not go back, because he was not heating it up, he was not cooling it, he was just doing it for the time being. And why does it happen? So, when you move or bend any material including the fiber or a filament. So, one side you know is compressed, the other side is extended, which has to happen because you are bending. So, bending resistance has something to do with it. If it is very resistant material, then it will be difficult to bend. For example, this pen is difficult to bend, but this material is easy to bend. So, there may be what I call as a possibility of thickness which will be playing the role, the diameter of the yarn may be playing a role, all that is important. All right. Now, the trick remains, can you stabilize this structure? What is this structure? The structure is that when you bend, part of it is compressed, outside is extended, and you keep this as it is, then it will remain in a bent condition. Like for example, this paper, I have bent it, I am expecting that inside of this is compressed, outside is extended, true, but I leave it, it comes back. I do something like this, now it does not come back. Something has happened, some change has happened, and this change is not allowing it to go back. And that is the kind of change, if you do smartly, then the kind of structure that you are getting, this helical structure, will be in some sense permanent. Nothing is permanent in the world, it is all relative. So, it is going to stretch, it is going to compress, it is going to recover, stretch, recover, stretch, recover. This is what will happen. Think of this. The one who actually postulated must have been a proud man or a woman, right? Like a very simple technique you do. So, this is also important to learn in this whole growth of texturing. Is a lot of people have been giving different ideas to ensure different kind of products are generated, and so it is very interesting. So, this is the principle. So, interesting part is that you can get a helical structure without twisting and get of course stretch yarns. So, this is one part which we thought was interesting, that you could make a helical structure without any just passing over an edge. A helical structure is useful, so it is useful. The question that comes is, can you twist without a twister? Now, twisting we know obviously will produce a helical structure, but if it gets twisted, it will produce a helical structure. But can you think of something where there is no twister and it still get twisted? That is, you have no twister and it still get twisted. Once it is twisted, then we will know what will be the best thing to do, how will it help anyone for that matter. Any guesses you may like to make? Or you can also say, well, this is an absurd question. I mean, you can't do things like this. You can't go to hostel for that matter without walking, unless and until the hostel can come to you, which can happen. But nevertheless, there is the question. So, you give some tension and then suddenly find it starts getting twisted. Well, not a bad thing to actually think about it. So, he has got some idea I think what we will do is that we will give him some assignment to actually design a process by which this would happen. So, we would not discard the idea, ideas are always good, right. It can happen also. But let us see what people did. This process is called turbo duo process. So, what this process is doing is, there are two packages, package number 1 and package number 2, which are the packages which are untwisted, untextured feed yarn, and then you want to texturize them, but before you texturize them you must twist them. So, what they are doing is, take one yarn from here, take the other yarn from here, give some pre-twist by any method, any method. You can just do this and you have a twist, and then whatever length and whatever twist per meter you wanted, you give, and after that just go away. Just remove the yarn from here and from here and then start winding. So, what you have is, actually you should have a feeding mechanism, you should have a feeding mechanism. Why this feeding mechanism is required? What is important is that if you do this and just keep pulling, as long as the yarn is being fed, you will suddenly find this twisted zone just remains there. The new yarn comes in the zone, get twisted, and as it gets out of the zone, and that portion where the twist is there, it just stays there, maybe a little bit of vibration based on what you do. So, there is no twister now, but this also you must have seen in your life. Some people must have used it, doing all kinds of things, but this is something which is possible technically to actually do the twisting. This twisting is slightly different than the previous twisting, because now you have two yarns, so it will be a ply twist, right. So, two yarn going to be twisted over each other, but that is okay. So, now how do we do the smart thing? The smart thing would be that you have this you are pulling, you are feeding, in between when you think you are right space, put a heater. Cooling. So, again we are assuming it is a thermoplastic yarn. So, what is the smart thing? That you have been able to twist without a twister, and using that zone, the zone could be made longer or shorter based on how much twist you have inserted. So, if you insert more twist, then it will spread. But important thing, there is a tension in this yarn here, there is a tension in the yarn here. You can appreciate if both T1 and T2 are far away, not very close to each other. In fact, if they are same, that is the best. If T1 is equal to T2, then the same amount of yarn is going to be fed. If T1 is higher, then this whole zone is going to be pulled towards one side. If T2 is higher, this will be pulled on the other side. and if they are same, this point will remain exactly, approximately, theoretically exactly same. Practically it may go up here and there, because you may have variations. You can't obviously say there is zero tension variation. If there is no zero tension variation, something will be there. Let us say theoretically we want to make T 1 is equal to T 2, and also at the same time you should be able to make T 3 and T 4 also same. If you do these conditions, then you can continuously keep feeding the yarn into the twisted zone and continuously keep withdrawing from the twisted zone, and this so called twisted area or a length will more or less remain stationary at the same point. It will appear to be there, remaining there. Smart thing, isn't it? So, when somebody was saying that I can do this, yes, that is also a smart thing and you must do. So, do not leave that part, but you suggested think as to how will you do it. So, an engineer is supposed to design, take a problem and start designing. Do not say that it can't be done. How it can be done is the more important thing. So, it will be interesting as to if you find some solution other than that. And of course, you wind them, and this wound yarn should be a textured yarn, because what have you done? You have twisted, you have heated, right, and also you have cooled. So, it should be meeting all your requirements. Is that a continuous process? The edge crimping was a continuous process. False twist was also a continuous process. So, you have a continuous process, 3 continuous processes that we have seen. One of them was a batch process, and we have seen this twisting without a twister, and also we have seen helical structure without even twisting. So, let us have a summarize. Stretch yarns, Helenca multi-step process. It also gives you a helical structure, but it is a batch process. False twist texturing is a continuous process. It also gives helical structure. Edge crimping also gives helical structure as a continuous process, and turbo duo we just finished also is helical process. It gives you helical structure. Why? Because the common factor is twist. No, it is not. Common factor is that in some way we are actually making helical structure. That is the common. In one case we are not twisting at all, but we are getting helical. So, what do we learn? What is what we learn? We learn is that if you want to make a stretch yarn, you make helical structure. Why? Because they will extend the maximum. You can get any structure, it does not matter. You disturb the yarn in one way or the other, you will get some structure, all right, not an issue. But you will not be able to get that much of a stretch which we are saying 300 to 400%. Now, how much stretch? It will depend on how many helices you are putting per unit length. Larger is the number of helices, more will be the stretch. Of course, this will be related later with the denier of the filament, the diameter of the yarn, etc. They will be responsible, but definitely you can take away it must be helical, and all of them produce helical. So, what it also means is if you have another process, continuous process or any other process which can give you helical structure, you will be able to produce a stretch yarn. We go to the next step, which we called as a modified stretch yarns. Now, you remember why did we call it modified? Right. So, you want to reduce the stretch. That means you first make a stretch yarn and reduce the stretch, and therefore, you are modifying the process. Therefore, the term has just stayed. What actually it means is the yarn characteristic, basic characteristic is it will still have bulk, but it would have less stretch, okay, maybe 100 to 150 or so, right. So, the smartness will be how to reduce the stretch. Principally, we have understood we can make stretch yarn by using different principles. So, if it is modified, that means you have to go to that step initially. First, you make a stretch yarn. Okay. So, let us see if the same processes can be used to do the modification. So, we do have this process, right, called the Helenca process. So, what was the Helenca process? Set, no, twist, set, detwist. We got a textured yarn which was called a stretch yarn. Now, we have to go further from there. And what do we do? After this detwisting, we have made a package. Here a term which has been used is soft package. Soft package. What is soft package? That is the tension, winding tension was less, and therefore, the yarn or the filaments within the yarn have some scope to maneuver, right. After that, you do resetting, put it back into the autoclave again. If again remember thermoplastic, if the thermoplastic fiber, then you use the heat, that means again an autoclave. So, package twisted somewhere, put in the autoclave, take it out, obviously cool. After cooling, take it to the detwisting zone machine, detwist, softer package, and then after making a soft package again put it back to an again autoclave, and do not do anything after that, cool it, and this is your modified stretch yarns. So, the question is what have we done? It is just taken and then put it somewhere, and then suddenly it becomes modified stretch yarn. So, what are the tricks here? What is the principal trick? What is the principal trick? Can you guess? What have we done? Take the package again and put it somewhere else. Reheating the same thing, you had cooled, untwisted, again reheating. So, the heating reheating makes change. So, does it somehow satisfy your inquisitiveness that you take something, heat it once, then cool it, again reheat it, is going to keep changing the property, and the property the way we want to change the property. I mean, it is not that. Good. So, one part that he just said is the temperature could be different. Temperature of resetting could be different, all right. So, should it be high or should it be low? High or low? Low. So, that means the second heating system or a cycle would have a lower temperature than the primary or the first heating cycle, right. So, if you remember your thermoplastic yarns, polyester etc., you iron, you put a crease, right. So, you wash it, the crease stays there, but if you want to remove the crease, then you go to the temperature which is equal to the previous temperature or above, then you can remove the crease. But if you remain below, can you remove the crease? But you cannot say nothing is happening. You see, it is a polymer, there is something called a glass transition temperature. If you are above the glass transition temperature, something will definitely happen, some change, but the change would be limited change. It will not completely change that. Now, somebody asks you, you are already in a helical thing, yarn has been texturized and you are reheating again just to the lower temperature. Is it going to be in your benefit? How is it a benefit? Okay, lower temperature, some change, but it is still helical. It is still helical. So, how is it going to help you to reduce the stretch? Good question. So, what we are going to do is, we will stop here, okay, and continue in the next class, starting with this question itself as to how is it going to help you to reduce the stretch. Like you have the crease on a shirt, at a lower temperature of ironing, you take the same crease and put your iron, will the crease go? If it does not, then how is it helping? Right. So, we leave you here with this question and well, we stop here.